Hi everyone, welcome to Beyond Public Buckets, Lessons Learned on Attack Detection in the Cloud. I'm Nick Jones, I'm a Senior Consultant at F-Secure and I look after our cloud security services globally. With me today I've got Alfie Champion.
Hi everyone, I too am a Senior Consultant at F-Secure Consulting and I look after the attack detection services.
So for our agenda today, we've got a few things we're going to talk through. First off, a comparison between on-premises attack detection and cloud. There's a fair few nuances there that are worth understanding before we go much further. Some discussion around how to design your detection stack for the cloud, how to integrate the different technologies involved, talking through some of the likely attacker activity you're likely to see. A lot of that's quite specific to your own environments, but it's worth talking through the generics as far as we can. And lastly, our experience is taking the methodologies that our friends over in the DevOps world use and applying those to attack detection.
Great. So on-premise versus cloud then, to kick us off. So let's just, I guess, lay the foundations and compare this to on-prem. Is this like a solved problem already? Are there lessons learned from on-prem that we can carry over into cloud? Well, I think from Nick and I's experience, there's four kind of key areas that are of most interest. And the first is this idea of the uncertainty of malicious intent. The idea here that at this point, when we're working with a cloud account, certainly at the cloud account level, much of the actions that we're taking are through published APIs, the kind of intended use. So much of the known bad, the kind of things that you'd see on-prem being catered for by the likes of maybe antivirus, for example, are kind of more few and far between. And managed services like AWS's GuardDuty provide some good coverage in that known bad space. So the likes of beaconing out to Tor IP addresses being a good example of that. Similarly, context is ever more key when it comes to cloud detection. So as I've said, with much of this API interaction going on, understanding an action, the intent behind an action and the context of it can be crucial in building kind of high fidelity detections, really. Thirdly, gaining visibility on the face of it is easier. So with AWS as an example, we can have kind of organization-wide cloud trails. We can adopt some kind of account vending policy such that a baseline level of logging is maintained across the various accounts that we have. And then indeed, like your biggest problem becomes something like shadow IT, where actually understanding the cloud environments that you're operating in can be your main concern at that point. And then lastly, less about kind of how you do cloud detection, maybe something to be more mindful of really, is that attackers are automating. This is like an economies of scale type thing here, where they're leveraging kind of scripted attacks such that the compromise of some access keys, maybe that's through some unintended exposure through, say, a code repository or something, that can lead to an EC2 being spun up in some obscure region and a crypto miner being installed in mere moments, effectively. So understanding the pace at which some of these more commodity style attacks are happening is something to definitely be mindful of, I think. So threat actors then kind of, what are we dealing with and what changes as we go up that level of sophistication? What 1, 2, and 3 here we've got? Well, the first thing is to bear in mind that kind of, as I've mentioned already, that commodity style attack. And I think much like we see from the kind of cyclical process of vulnerability disclosure, some patch release, and then potentially some mass exploitation, there's kind of some parallel here as well. If credentials are compromised in the likes of GitHub or on an exposed S3 public bucket, for example, as I've said, there's a very, very quick turnaround when it comes to that compromise leading to some account action that's obviously with some malicious intent. As we move up that pyramid, we start dealing with more targeted attacks, whether that's application vulnerability, whether that's a targeted attack through, let's say, a phishing vector, for example. And it's at that very top, very bespoke TTP angle that Nick and I have spent our time really, I think, with our clients most recently. And I think when you get there, there's a bit of a mindset shift that needs to happen. When you, again, going back to that on-prem, there are obviously bad things, and the classic kind of evergreen example is something like Mimikatz. If Mimikatz is dropped to an on-premise device, there's a known hash, there's some behaviors there that are so obviously bad, if you like, that you've got some reasonable confidence that you can act on those, with quick speed there, really. In cloud, there are fewer of these, as we've said. There's less obviously bad things. Everything is abuse of legitimate functionality. And as I've mentioned, context becomes the key thing here. So as a simple example, we take a given IAN user, for example. This user is then provisioned with admin access of some kind of relevant, means. And then if we take a look at how that actions took place, if that change is made by a CI/CD user, there's some relevant change control associated with that event. The likelihood is, and obviously there's always edge cases to this, that action is probably okay. The intent there is legitimate and it's not a malicious action. If that change is made by an admin with no 2FA, maybe we've enriched our data to say, with the GeoIP that this is coming from an unexpected place. There's no audit trail to suggest this should be happening. That could give us more information and could act as an alert and something that instigates some kind of investigation. So on-prem telemetry then versus cloud, kind of what's at our disposal then? We've said that the visibility is easier, there's more at our disposal. Well, what are we talking about there? Well, I guess when you consider on-prem, there's the obvious candidates there. There's your host-based telemetry, your network-based telemetry, and your application telemetry. Network telemetry, we could be looking at some kind of like IDS, IPS, host-based, EDR, AV, and the application telemetry can obviously vary based on what we're talking about here, but that could be some vendor-provided logs, that could be some custom-developed logs that you're providing as part of that application. When we consider a cloud workload, though, some of that remains and some is less important. So the most important thing, I guess, is the control plane telemetry, which kind of encompasses everything we're talking about here. If you consider what's commonly called a kind of lift and shift approach to that cloud workload, you may retain all of these. You may have host telemetry, your EDR could still be rolled out and would still be relevant. Your network telemetry indeed could similarly be relevant to some degree, and your application logs are likely still to be relevant. But if we start considering cloud native workloads, some of those could go away. The idea of deploying an EDR to an entirely kind of cloud native workload could just be a non-starter. It just wouldn't work. And similarly, that control plane becomes such a critical source of information for you as a defender. All the API calls we've spoken about, the intended functionality, 9 times out of 10, it's in that control plane telemetry that we're going to be looking at. So just to pause for a second, then we've kind of thought conceptually about on-prem and cloud and what the differences might be. Well, just going to take a moment to look at some of the mistakes and pitfalls that we see from clients as they pivot from their on-premise detection, particularly those with a mature outfit already, and take that over to cloud. And I think the first one we see, and this is quite common, is that telemetry is aggregated with no context. And I think that there's two main things to say here. One is, by no provided context, what I mean is not only is it that log source has not been enriched when it makes its way to the SIEM, so there's no way of knowing kind of in which account it belongs to, aside from maybe the account ID that's provided alongside it. But more importantly, there's no way for your analysts, for your investigation team to pivot into an account to understand maybe more about what's going on. If they've got some kind of federated access into those accounts to actually perform the investigation in a streamlined, effective, and formalized way. And as I've said there, what is bad in one account could be good in another. And you need that context, as we've said, to figure that out. Another thing is overlooking authentication logs. So we're talking about kind of on-prem, if you imagine that kind of top and bottom, on-prem logs. And then we're talking about your cloud-based logs, the control plane stuff we've mentioned. But there's that interface in the middle, that trust boundary, or at least conceptually, when it comes to the federated access. Any organization of a decent size is likely to be managing various cloud accounts and indeed doing it in some kind of federated way that relies probably on a single point of truth. Getting the logs out of that is certainly going to be valuable for doing some meaningful correlation between the events you see. And a good example of that is probably the Golden SAML attacks that have been made very noticeable in recent times. And I think it's important to mention as well, what we're talking about here, this idea of kind of what are cloud accounts providing us when it comes to telemetry and what the differences are. It's never too early to threat model these, to start thinking about how would I attack this? How would I subvert the controls that I've got in place here? And just to test out some of those offensive scenarios. And the best way to do that is to build the context from the architectural stage onwards. So don't think about it as like I'd go through my development cycle, we're about to deploy. Okay, now I'm going to start thinking about what I can detect. I've got some log sources turned on, which harks back to my first point there about kind of providing logs aggregated with no context. building this in from the start to say, what should the environment do? Maybe what should it not do? And then provide that insight to your analysts directly. So they know when they're dealing with this, when they're triaging events, and even when they're building detections, this is what I should see, and this is what I shouldn't see. And the codifying of this and the documenting of this is something that Nick's going to speak about later on in this session. So Nick, I'll pass back to you.
Thanks, Alfie. So we're going to talk now about designing your cloud detection stack. What we mean here is, how do we go from not having anything to a stack of technology that ingests the right logs, presents them in the right way, and that our analysts can get some useful data out of. Now, our first tip here, I think, is as much as the industry likes to go on about the idea of a single pane of glass, useful but perhaps not necessary. What is necessary is to make it very easy for your analysts to pivot between different environments, different providers, different data sources. The real critical thing here is that attacks rarely happen in isolation in a single environment. It's very likely an attacker is likely to try and pivot or laterally move from your on-premises estate into the cloud, or vice versa, or between two environments. And so analysts need to be able to look at logs from one data source and easily pivot into the next. So now let's actually talk about some of these data sources, right? So we've got two key ones that I really want to focus in on. The first of which is the control plane audit logs. The second of which is the service-specific logs. There are a number of other logs available, some that will remain relevant from your on-premises estates probably. Things like, if you have virtual machines, put your endpoint detection and response products on them. Likewise, network flow logs. If you have a lot of virtual machines running, you're likely to get more value out of those than a serverless cloud-native environment might. But these are things to analyze on an environment-by-environment basis. The two that you really should always be looking at are the control plane audit logs and the service-specific logs for the services you're using. So first up, control plane audit logs. So here we're talking CloudTrail for AWS, audit log for Azure and GCP, but also Kubernetes audit logs have proven quite a rich data source in a couple of client environments for us as well. And the real key thing here is what these do is they log every action taken against the API provided by AWS, Azure, Kubernetes for managing the environment. Any resource creation, destruction, alteration, or modification, you will generate logs here for it. And that provides you with a trail of event data which you can analyze to understand what someone has done in your environment. A couple of key considerations. First of which is, for AWS, you need global events and multi-region logging turned on. It only logs to a single region, or sorry, for a single region by default, which has caught a few people out that I've seen. And it's worth centralizing these, as we spoke about before. All the providers offer some kind of organization-wide centralized control point where everything gets logged into the same place. Well worth taking advantage of those. Then next up, we have the service-specific logs. So here, I'm thinking about things like your object level logging for S3 in AWS, or your Lambda or Azure function execution logs. And in certain environments, for certain key resources, these can generate some quite useful telemetry. If you know that you have an S3 bucket containing lots of sensitive data, keeping a very close eye on the data events happening in that bucket is very useful. That said, if you've got an S3 bucket that just serves data, JavaScript assets, things like that, as part of a web application, you probably don't care about read events. So you can filter all of those out. Write events, on the other hand, might be quite useful for spotting sort of Magecart style website defacement, JavaScript alteration attacks. But this is entirely case by case. You have to look at your environment, work out what it is that you can get value out of, and enable those specific log types to stop you spending your entire security budget with Splunk in log ingestion fees. So in terms of how to prioritize this stuff, where to start with this, you want to make sure to gather telemetry for the services you're using. It's quite useful to filter out all of the data that may come in from services that you know you're not going to use, especially if you're able to put blocks on those services being used, service control policies, for instance, in AWS. And then really look at what an attacker is going to try and do for a given environment. What is the key business level attacker outcome? What are they going to do to achieve that? And then work backwards from the objective end of the kill chain, where you'll get the highest fidelity alerts. Great.
Yeah. So we've spoken about this then. So this idea of likely attacker activity, we've spoken about the log sources that might be at our disposal. But what are we looking for? Well, I think just going back to that comparison of on-prem to cloud, and I think one of the things that strikes me here is that when it comes to on-premise, things are I think when you consider industry scale, reasonably homogenous. You consider the endpoint at your disposal, you consider your maybe your web proxies, etc. And there's some degree of commonality from a state to a state, and there's some degree of commonality in terms of how you might overcome an organization's defenses to achieve some malicious objective. And I think in many cases, certainly not all, but in many cases, the cloud workloads that we're talking about here are bespoke ones. So the caveats to that, of course, are when we're dealing with maybe like an extension of our corporate environment. So we just have like a peered network where maybe our server estate has been, as I said before, lifted and shifted into AWS, for example. It could be that a lot of the parallels there are the same, and it's almost transparent at a network level when it comes to interacting with those assets. When we start thinking about purpose-built, cloud-first, cloud-native, all of those things, it could be that environment is entirely bespoke. And as such, the attacker actions that are performed within them need to be bespoke as well. We need to behave in a certain way to achieve the goal that we're after here. And I think at this point, it's worth mentioning as well that we're talking about simple examples. In the previous diagram, I had like a couple of EC2s and a Lambda function, but you consider enterprise scale, certainly the kind of modern kind of startup style kind of consumption of third-party services. That cloud adoption is insanely complicated. I mean, you could be talking about trust boundaries that exist between services entirely outside of your classical kind of organization kind of perimeter, if you like. You could be looking at cases where you need to be consuming the log sources from those third-party providers and relying on the fidelity, the completeness of those sources to achieve some meaningful detection within them. So what we're talking about here is hopefully conveyed as a principle, a way to get started, but it's just worth bearing in mind that there's a bigger scope here, and that's something that's going to become apparent as we progress through the session as well. Leading from there, then, I think one of the obvious candidates certainly that served us or has been invaluable on-prem has been MITRE ATT&CK. The enterprise matrix there on the left-hand side of this serves to allow us to convey the attacks, allows us to link them back to perform some kind of mapping and some meaningful tracking as we go through from threat intel to kind of security control proficiency, everything. And it obviously serves us in cloud as well. In comparison, the cloud attack matrix is relatively immature and less kind of complete, if you like, or contains less attacker actions. I think when you look at the enterprise matrix, you can get right down to the granular level of use run DLL32 to achieve some code execution. And it's that granularity that I think is something that we'll certainly see more of as we progress and as the cloud attack matrix progresses. And there's some great work from various individuals and kind of companies within the InfoSec space, the likes of Scott Piper and Spencer Geitzen, the guys at Rhino Security, GitLab as well, putting out some really great research, some great tooling that kind of allows all of us to understand what it is to attack and defend cloud environments. There's some great stuff there. So getting down to that granular level of what is it that an attacker is likely to do? That's why we're here. Like, what are we going to be looking for? I think for Nick and I, and indeed kind of the practices we lead, it comes down to kind of relying on our own experience, what we've seen before, what's worked well. And just to give you some examples of some of the entry points that I think conveys kind of what's possible, but also some of the complications that I showed in that spaghetti diagram before. The first is identity management as a way in. So we've already spoken about this idea of either public repos or indeed globally accessible repos that are internal. So any user within an organization can access that stuff. If there are credentials found within these, that could lead to potentially direct cloud workload compromise, but also it could lead to upstream compromise as well. So consider things like if there are credentials to like an artifact repository, if there are credentials that provide access to our pipelines, the configurations of our pipelines, that can be a huge thing. And as we'll see, it is covered off in the idea of source code management and CI/CD. And similarly, and kind of linked to that, I guess, is this idea of pivoting from other environments as well. We've seen this in several cases, kind of most notably in the SolarWinds case, where what we're doing is compromising on-prem. And then when there's that source of trust lies on premise, that we can move from there with some assumed level of privilege and the trust that is kind of put from the cloud provider onto us when we access those assets. And that can provide a very powerful way to essentially arrive at the doors of your cloud account with all the access you need to do what you need to do. So there's no need to pivot through it to obtain kind of full control, if you like. And I've already touched on this, but it's worth bearing in mind kind of what this really means, really, I guess. So when we consider our cloud environments, the kind of the DevOps ethos that surrounds it in many cases, one obvious target is infrastructure as code and the repositories that it is contained within. The ability to change infrastructure as code within its repository, let it go through a pipeline or indeed attack the pipeline itself could lead to us introducing kind of new users to that cloud environment, misconfigurations, intentional misconfigurations, or adding network access, SSH keys, kind of user imagination there. So I think what I'm trying to say here really is when you're considering your cloud workload, that is invaluable. That's something that we've certainly spent a lot of time doing, but do bear in mind where the trust comes from with that account. Where is the upstream sources there that are pushing information down into the account and could be compromised essentially outside of the scope of the cloud account itself. And lastly, just as a counter to that really, is application vulnerability. So this is effectively traditional internet-facing app vulnerabilities that we've seen in the past. This idea of kind of high-profile disclosures coming out, leading to widespread compromise. If those servers, if those appliances are being hosted in a cloud environment, it potentially makes very little difference when it comes to the compromise of the asset itself. If that provides initial access, if we're looking at a peered network where our server estate lies in AWS, along with, say, an exposed application that's vulnerable, that could provide the pivot point. You could get to there, and then from there, pivot further into the environment, whether that's within the cloud environment still, whether that's going into the on-premise environment. All those things are up for grabs. And when we consider back to the pyramid that we had before, this could go any number of ways. Once you've obtained initial access, it could be that access is retained by the original party and they go and install a crypto miner, and then we see something like guard duty flagging or something like that. Or it could be they sell that access on to a more sophisticated group, and then things take a turn and they go down a different path. But all of these things are worth bearing in mind when it comes to the security and certainly the detection engineering angle of what we're dealing with here. So how do we start then? Well, I think we've already mentioned this, but this idea of threat modeling your environment, identify the attack paths. And we've already said there's a few things to use as inputs to this. So the offensive research we've seen from guys who've already mentioned, the attack matrix as a way of kind of narrowing your view there to kind of focus on a few things in particular. But then also, as Nick said, the critical flows here, like what is business critical information? What is business critical functionality? Consider the attacker objectives, consider the starting points. What are the threat agents that you arrive at with this threat model? And then from there, prioritize the attack paths. If there's something there that's like, this is our kind of black swan event. If this happens, this is game over, kind of, turn the lights off on the way out type stuff. That is where we need to be spending at least in the first instance, where we spend our time and we put our focus into. So pick those paths, prioritize those paths, and then start to deconstruct, understand the TTPs, the tactics, the techniques, the procedures that those attack paths could consist of. And just as Nick has illustrated there, we can look at the log sources that are at our disposal for detecting those things and verifying that telemetry is indeed available to our defenders. And then lastly, execute these attacker actions. Obviously do it in a sensible, controlled, change-controlled environment. But actually kick the tires on this. Try out the attacker actions, do them as kill chains, even do them as an isolated event, just do them atomically, and verify that the detection cases that you've developed or that you rely on work as expected. And I think this slide says, how do I start? But really, I think this is an operating model that extends past that. If you consider this where the complexities of this, you've got log sources emanating from one account, maybe moving into a centralized security or indeed a logging account, and then making their way potentially further into a SIEM or some analysis kind of pane. That is complicated, and mistakes happen. They do happen. We've seen it ourselves. So actually performing this on a regular basis can allow you to validate that entire pipeline from the source to the end, to the analyst, seeing it in their hands, seeing it in the portals, and allowing them to kind of pivot into the accounts and understand what's going on, to triage the alerts, is a valuable exercise. So just as Nick has said, where do we start? Well, potentially at the objective end. So if we're talking about the exfiltration of sensitive data, if we're talking about even down to the crypto mining example of installing and kind of deploying a high-powered EC2 for crypto mining, um, understand what those events are, kind of catalog there, make sure that's all written down, and then from there, start building the detection around them. What are the API calls I'm expecting to see here? What are the log sources that are going to contain those API calls? And we've touched upon this idea, the DevOps principles, and kind of, I guess what leads there is the treating everything as code kind of thing. And what we can do is codify our detections. And we've seen a few examples of that, some really popular examples of that, in fact. Sigma is a great example. So that's a community project there, started by Florian Roth, which allows us to codify detection kind of concepts, detection logic, and it's SIEM agnostic, right? So we can apply that to whichever SIEM it is we're using, wherever our events ultimately make their way into. We can use this to not only kind of bootstrap our detection capability, but also to share as well. So if we have things that we think are valuable, not only can we provide them across the community, but also from team internally. If there's attacker actions that are meaningful to you, then it could be that the other application teams, the other cloud engineering teams that you work with could use them as well. And that fostering that, evangelizing that is key. And one source, which I know Nick is going to speak about in just a moment, is Jupyter Notebook. So I'll leave that to him. But lastly, I mentioned John Lambert's talk there on the GitHubification of InfoSec, which I think encompasses basically all of the things we're talking about here, from codifying, from using Jupyter to share, to correlate, to provide a kind of process and a thought process for how we go about these things and how we share them with each other internally and externally. So I'll pass over to Nick then for how we can bring DevOps into detection.
Absolutely. So we took a look at what we were doing. We took a look at a lot of the DevOps-ification efforts, to use a horrible buzzword there, that were being undertaken by a few of our clients, and we took a step back and we built some tooling around this, which we've released as open source. So, Alfie, Leonidas, please. What we're talking about here is an automated attack simulation tool. It's a framework for defining, executing, and validating your detection of a set of attacker TTPs that you define. Currently AWS, and we've got Azure and Google Cloud on the roadmap. Everything's defined as code. All of the detection rules, all of the attacker actions, it's all codified. And the framework itself automatically generates both the serverless API that at the moment runs in AWS, but Azure and GCP on the roadmap, as I say. It will generate Sigma rules, but it'd be fairly easy to generate other rule sets as well if you were interested in doing so. And also some documentation. You can run a multi-cloud copy of Leonidas in a single instance, so you don't have to deploy it into all the providers. And it supports user role service account impersonation. So you can do really quite a lot with it. Alfie, let's have a look at the diagram for this then. How does this break down? So we have some analysts, we have our purple teams, perhaps they define some TTPs. These are then pushed up into a continuous integration deployment pipeline. So you have a rapid cycle between new TTP is defined and we're able to simulate it. That's deployed as a Lambda function then. And what we do is we execute API calls against that Lambda function, and that triggers actions on target resources specified by your API calls that you're making there. And that then generates logs which go into your SIEM account. And we'll talk through a little bit more about how this works specifically in a second in the demo. But one thing I did want to highlight quickly is the documentation. We found documentation generation to be a very useful thing because it allows you to embed organization-specific notes and comments about these attacker activity inside the code, and then automatically generate a nice, pretty documentation website that your analysts can use to work out what's going on when a given alert fires. So let's demo some of this, I think. As we mentioned, Leonidas is an attack simulation framework to simulate attacker activity within the cloud, in this case AWS. So before I launch into Leonidas and how it works, I think let's talk through what a Leonidas case looks like. So this here is the enumerate CloudTrails case. CloudTrail, as we mentioned, is the audit log for AWS. So this defines what MITRE IDs we're tying it back to, some other metadata about it, the permissions needed to execute it, and then how to execute it. In particular, you can see down here we've got a single line of Python code that executes the describe trails API call using the underlying AWS Python libraries. So that single line of code there is all an analyst needs to write to make this detection case work. The framework takes care of everything else for you, which means you can give this to less experienced analysts, people without much of an engineering background, and they can get going with it quite quickly. We also embed the detection data in. So here, we generate Sigma rules off the back of these definitions, but we define the data source you look for it in, event names, event sources, the kinds of data that you can use then to build rules in your SIEM. So now that we've seen what a Leonidas test case looks like while you're defining it, let's actually execute a kill chain with it. So typically we interact with Leonidas using Jupyter. Jupyter is a data science tool for those not familiar with it, but it also works really nicely for just experimenting with different things in Python, producing some nice graphs, tables, all of these kinds of things. So first off, let's load it in. Then what we're going to do is just have a quick look at the test cases that we've currently got defined. This particular instance has about 40 test cases, I think, and it's a good variety of persistence, privilege escalation, some discovery work there as well. So we can simulate an entire kill chain with the test cases we've got defined. That's what we're going to do. So first off, let's see who we are. Who are we executing as? Here you can see we are a Leonidas role. This is actually the role that's tied to the function, the API, when it's deployed. So that comes with a set of permissions that are defined by the test cases that you configure, that you have deployed in this particular version of the API. So let's now see if our actions are being logged, if there's an audit trail running. This is the test case that I showed earlier that we've just compiled and uploaded. And here you can see we've got a couple of CloudTrail trails configured. This is useful for an attacker to understand what they might do that will get spotted, what might fly under the radar. But now that we know that we are being monitored, we're going to go for broke anyway. So we're going to add an IAM user as a persistence mechanism so that we can come back later. So you can see here we've now got an RSA user, IAM user. We're now going to add some API keys so that we can use these later. And now that we've got those API keys saved, we can come back to them in a bit, right? So we're going to add some permissions to it. In this case, we're going to go overboard. We're going to give it administrator access. And so now we can make use of those credentials that we previously generated in order to simulate the rest of the kill chain, simulating an attacker stealing some more credentials or doing some lateral movement, these kinds of things. And so what we're doing here is we're defining a new credential block, and we're passing that into Leonidas as part of the API call so that Leonidas can use those credentials to become that user. So here then you can see when we run getCallerIdentity again, this time around it's coming back as an IAM user that is called RSA user, this one that we created earlier. So we can now use that as well to then do some sensitive data exfiltration. We're going to enumerate some secrets, and it turns out we've got a secret configured. So let's get the value of that secret, and that's come back. We've got a fake API key in there that we can take away. So what we've done there is execute a complete kill chain from start to finish purely by making API calls to the Leonidas web API. And what that does then is execute those in the background using the Lambda function and returns the results to us. So we've done a whole kill chain of initial discovery, some persistence, privilege escalation by assigning new permissions to that persistence mechanism, then enumerating and exfiltrating some sensitive data. Now, we also mentioned that Leonidas comes with its own audit trail. So going over into CloudWatch, we can take a look at some of these from earlier. So you can see here, we've got the first getCallerIdentity, then enumerate cloud trails, add the user, add the API key to the user, and the audit logs that Leonidas creates gives you the data from the request itself, but also the response. And you can use this then to compare the requests made to Leonidas against the logs you're seeing in your SIEM and make sure that the right signals, the right use cases are triggering in the right places. And so you can use this as well to simulate testing across environments, on-premise, up into the cloud, combine it with things like Mitre Caldera, to get complete coverage across your whole estate. That's another really powerful story that is still fairly early days for experimenting with it, but I think there's a fair amount there. And we can use it also as part of the idea of continuous detection validation, as I mentioned in the demo, the idea that we check new rules in, those get run through the CI/CD pipeline, deployed to the SIEM, and we use Leonidas then to verify that this all works correctly. And that's quite a powerful story that, again, we've been experimenting with and has really made a significant impact in a couple of places.
Great. So in conclusion then, I think there's a few things to draw out really. The first is what we're talking about here isn't necessarily a solution, but more of a process, a workflow to go through, and something that can hopefully be scaled out to your various application and infrastructure teams. And as your cloud environments change, just as Nick has said, your detection will change too, that the log sources you need, the attacker actions that you're going to need to simulate and that are relevant will change too. Indeed, as we've said many times, context is key. Understand, you know better than anyone what your environments are supposed to be doing and maybe what they shouldn't be doing, and you can use that to your advantage. And finally, hopefully with the tool set that we've seen here, you can codify and share your use cases and indeed your attacks to aid knowledge sharing internally and with the wider community as well. So applying what you've learned here today then, well, I think next week we're talking go away, identify the existing policies when it comes to logging and confirm that aggregation, rather than we're logging, but they're just going to an S3 bucket and that's the end of it. Are we aggregating those logs? Do our responders, do our analysts have somewhere they can actually go and see them all? And similarly, are you kind of making use of the quick wins, the likes of guard duty, as we talked about, that caters quite effectively, not only to the base of that pyramid, but further up when it comes to the known bads, where they exist, are they being kind of catered for? And then moving forward, the next kind of 3 months, document the cloud workloads that you've got. What services, is there any commonality there? And then take an example workload and perform what we've described here, the threat modeling exercise, identify the attack paths, deconstruct them, get the TTPs, execute them, and understand kind of where your detection capability is really at, effectively. And then in the next 6 months, ensure your defenders have got the access. We've spoken about this throughout, really, but making sure that the guys on the front line, the analysts that are going to be picking up these tickets and these alerts, and indeed building the alerts in the first place, they're familiar with cloud attacks. They understand how to triage. They've got the processes and the actual technologies to triage as well. And then actually just instill this in your development cycle. As we said, it's never too early to threat model, to start kicking off that detection engineering process, to share this information and to capture this information. And then hopefully all this goes well, and you can evangelize this approach across your various teams. And then just as Nick said there, Leonidas is available on the F-Secure Labs GitHub. It's available now, it's available for free. So give it a go and let us know what you think. And that's the end of our session. So thanks for joining us today. And hopefully there's some questions in the QA for us. Thank you.